So in this video, we're going to start looking at the permutation problem a little bit more in detail, meaning that we're going to start looking at Python and going to take our intuition from a previous video and formulate that idea a little bit more concrete by writing some code here. Okay, so first thing, let's define a function here. So let's go at the very top and let's write a function. Now you might notice I'm being a little bit lazy here. I haven't even changed my module. I'm still calling it learning exceptions from one of my previous videos. So my apologies, I should have been named more appropriately, like learning recursion, for example. But anyways, we're going to use the same module and we're going to write a recursion in this module. So let's create a function and let's call a function permutations. Now what is it going to take in as an input? Well, it's going to take in a string. I need to pass in a string of some arbitrary length, and then I'm going to give you back a list of all possible permutations. It's going to give you back a list. Okay, so that's my function. And again, if you need to make this a little bit more concrete, the easier way would be think of this piece over here as an input. So just remember, this is my input, this is the input going into my function. The name of the function is right there, is called permutation. This is the name of my function, and somewhere within the implementation I'm going to return back, I'm going to have somewhere return basically a list of all the possible permutations for this input. Okay, so function normally has three important pieces: is the input that is going to the function, the name of the function, and then finally what is the return, what is it is going to give you back as an output. Okay, so given this idea, let's just continue writing a function. So that's the name permutation, and I'm going to give it a base case. The base case is that if the length of my word is actually equal to 1. What is a permutation? If the length of my string is just one character. Well, if the length of my string is just one character, the permutation of that string is just going to be that character itself. So instead of saying return word, right, just saying return word, remember the specs of my method is to give you back a list of all possible permutations. The permutation for a length 1 is just going to be one word, that character itself. So instead of giving back just that word, I'm going to give you back a list of that thing. The list just contains one item, so I give you back a list of that permutation. Okay, so this is my base case. That's my base case here. How do I know against my base case? Because this can be solved using non-recursion. I'm not using any recursion there. I'm not calling my function again. I'm just saying this is a point where I can solve the problem using non-recursion. All right, now how would I proceed with a problem where the length happens to be more than 1? Okay, if the length happens to be more than 1, one way to do this would be, let's put some comment here. So let's say, let's now get all the permutations. Let's get all the permutations of length n minus 1. All right, so let's say perms equals to permutations, and now I'm going to pass in a string that is a smaller version of my word here. All right, so what I'm doing here, what I'm doing at this point is this is the original problem of some size n. Okay, so the length of this is basically n. The length of this problem, remember this is a recursion, I'm calling the function again, permutations, and I'm going to pass in a problem that happens to be a smaller version of my original problem. My original problem was of size n, this is going to be of size n minus 1, because I'm just going all the way up to character 1 till the very end. Okay, so what I'm saying here is, look, I'm still in the process of implementing this. I'm still in the process of writing this method here, which happens to be permutations. But let's just make an assumption here. That if this method has been implemented correctly, what perms is going to be a list of all possible permutations of what? Of the string word from 1 till the very end. This perms is going to be the permutations of all possible permutations for the string word going from 1 till the very end. Remember, it's not all possible permutations for the original problem of size n. It's all possible permutations of a smaller problem of size n minus 1. Alright, so this was the intuition I was hoping that you guys got in my previous video. But then now let's take this idea and let's complete this a little bit further. So those are a list of all possible permutations. Then let's get the first character, which is word of 0. Alright, so I'm getting the first character out. Okay, so this is going from 1 till the very end. Whatever is the first character, I'm going to put it in a local variable char, and then I'm going to have basically a list called result, which is going to keep track of all possible permutations that I have calculated until this point here. Okay, result is just empty right now, but it's going to contain all the possible permutations for my string word. Okay, so this result over here, it keeps track. It is going to be a list of all permutations of word. All right. Okay. Now, what should I do? What was the intuition in the previous video? In the previous video, the intuition was that if I get back a list of permutations for a smaller problem, what I have to do is I need to iterate across each one of them. So let's go across each one of them. And what I really need to do is position this character appropriately at the very start, somewhere in the middle, and then at the very end. That's the idea, to get back the list of all possible permutations for my original string word. Okay, so let's do that. So now I'm going to say for I in range, let's make this go from perm to +1. I'm going to explain to you why I have that +1 in just a second, but let's just let me explain that to you right now, actually, before I write more code. Okay, so let's play with a use case. The use case is let's say word equals to ABC. What is perms here? Perms at this point is so perms is going to be a list of all possible permutations for word of 1, character 1 till the very end, meaning this entire piece over here is going to be the string BC. What are permutations for all BC? Permutations for all the string BC is going to be BC and CB. So perms is going to contain a list of these values here. What is char going to contain? Char is going to contain the first character of my word, which is A. That's A right there. So char is going to contain A. Alright, what is result right now? Well, result is just empty. It's just an empty list. I've declared it right there. Now for perm and perms, so this is what perm is going to be in the first iteration of my loop. Okay, perm is a local variable that is going to traverse every single item in perms. This entire list is perms, and perm right now is going to contain BC. And then I'm going to say, what is len of perm? Well, len of perm, in this case BC, is going to be 2. Right? That's the length there. I'm going to take that length, I'm going to add it to 1, which means this is going to be equivalent. It's going to be equivalent if this entire thing over here is 2. I'm taking 2 plus 1, which means 3. Okay, so range of 3 is what? Range of 3 is going to contain a list of 0, 1, and 2. Okay, now this is interesting here. I've got back a list. With these integers 0, 1, and 2. I is a local variable that is going to take on these values. It's going to take on 0, 1, and 2 on every iteration of my loop. Why am I doing that? I'm doing that because now I know exactly where I need to position my character inside this permutation of BC. So let me show you how am I going to put that together here. So now if I complete the inner body, I'm just going to say the result, which is the all possible permutations for my string word is going to be, I'm going to add my first result there, which is taking my local variable, the first permutation of my smaller problem, and I'm going to take that character, whatever the substring is at that point. I'm going to append it. I'm going to append it with my local variable char, which is right there. I'm going to put it right there, and then I'm going to append it with the whatever is remaining. Okay. All right, and now I'm just going to say, from my outer loop, I'm just going to say return result. Okay, so let's again just walk through this just to get an idea what is really going on. So from a previous explanation, what I said was range of 2 plus 1, meaning 3, gives you back a list. It gives you back a list which is 0, 1, and 2. What I'm going to do with this list is I'm going to have my local variable I take on these values. So I is going to be 0, I is going to be 1, and I is going to be 2. When I is 0, when I is initially 0 in the first iteration of my loop, what is the permutation, or in this case, again, if I were to just get my picture completed, in this case I'm going to have BC and CB. Okay, so this is basically a list perms over here, which is going to be BC and CB, and then I'm going to have my local variable take on BC and CB in this loop here. Okay, so in this, as this loop traverses, this is what it's going to point at in the first iteration, and the second iteration is going to point at CB, right? So it's going to take on these values here. All right, so what is this piece going to be? This entire piece over here, at the very first time the inner loop runs, okay, the inner loop at the time is I is 0, so this is going to be equivalent to that piece over there, plus character. What is char there? Char at the time is going to be equal to, if my word is ABC, char at that point is A. So I'm going to say whatever this is plus A, that's char, plus whatever is at that end there, meaning this is going to be my I is at this time 0, so 0 colon. Remember, this is the first iteration of my inner loop. Now what is this entire thing going to be? This entire thing is going to be the null string. It's going to be a string with length of 0. Alright, so this is going to be a string of length of 0. So let's just have those quotations just closing right after the other. I'm going to concatenate this with my string or the character A, plus whatever is from 0 till the end, which happens to be the entire string BC. What is the concatenation of all of these things? The concatenation of all of these things is going to be A, B, and C. Alright, so what does that mean? I've got my first permutation. I've got my first permutation of my original string ABC. The first permutation of my original string ABC is going to be ABC. And I'm going to take that ABC, which is from here, and I'm going to push it into my stack, or into my list result here. I'm going to push it into my list result here. So result at this time is going to contain my first permutation A, B, and C. Okay, if I runs the second time, when I run second time, it's now going to take in the value 1. So this is the first iteration. I takes in 0. When this inner loop runs again, I at that point takes in the value 1. I takes in the value 1. What does that mean? It means that now this 0 changes to a 1. This 0 over here changes to a value of 1. What is the character? The character is still a constant. Char hasn't changed. Char is still A. What is this entire substring going to give you at that point? This entire substring, when I is equal to 1, is going to give you going all the way from B. So this is going to give you just the first character, which is B. So now I'm going to have, so remember, this was when I was 0. Now when I is 1, what I now have is this entire piece over here is going to be the string, or the character in this case, B. Okay, plus in this case A. Okay, I'm just going to take A as it is. And what is this piece going to give you? Well, this is telling me on that permutation, on this local permutation BC, go all the way from 1 till the very end. Okay, so this is an index value 0, this is an index value 1, meaning starting from C, go to till the very end, which is just going to be, this piece is just going to be the character C. And there you go. What has happened now is, when I is 1, I've got back my second possible permutation of the original string ABC. This is going to be the second permutation. And what am I going to do with this BAC? I'm just going to take whatever the BAC is and again push it into my result. When I takes in the next value, when I takes in 2, so this is I equals to 0, I equals to 1, let's just do once more. What if I is actually 2? If I is actually 2, this piece of the code, 1 cancels out to 2, 1 over here cancels out to 2. Alright, so now I'm saying permutations from 0. Okay, remember this is the very start, going from 0 till the very end, which means this is going to give you this entire thing. This entire thing is going to give you, the string BC. Remember, this entire thing is going to give you the string BC. I'm going to take BC, concatenate that with the character A, that becomes BCA. And what is the permutation of 2 till the very end? Well, 2 to the very end, meaning this is an index value 0, this is an index value 1. From 2 to the very end is going to be the null. It's going to be a string with a length of 0. Meaning, if I concatenate that, it's still going to be BCA. And what has happened here is I've got my third possible permutation right there. I've got my third possible permutation for my original problem ABC. Okay, this was the first one, this one was a second, and this one was a third. And then the process is going to repeat again for the outer loop. When the outer loop goes from BC to CB, it's going to repeat the same process in the inner loop, and I'm going to get back all the possible permutations that I can create by positioning A appropriately on the substring CB to get back all permutations for my string ABC. So let's just run this to make sure we get this thing done correctly. So let's just have a use case here. I'm going to say print permutations for my string ABC. Okay, and let's just run this first to see this actually runs correctly. So if I run this, I'm going to get back a list. I'm going to get back a list of all possible permutations, which is ABC, BAC, BCA, ACB, CAB, and CBA. Now, if you're curious that am I even able to, can I actually step through my code and show you all the recursions that's happening? So I can do that. Let me right click on learning exceptions, click on debug, because I would like to now debug my code, and let's put a breakpoint appropriately. So let's put a breakpoint, maybe let's start right there. Let's just put a breakpoint at that point, at that instruction, and let's right click and click on debug. And I can see that originally the first time when my function permutations is getting called, remember this is my stack trace. If you're not familiar with this idea, I highly encourage you to watch my first recursion video to understand what is the information that has been conveyed to you in this window. So in this window, what was really telling me at a very high level is that inside the module learning exceptions.py on line 15, which was right there, this is line 15, this is line 15. On line 15, okay, what happened was there was the first call to the method permutations. Permutations started executing. This is telling me the current method, the method that is currently executing is this method permutations, and I'm currently at line 2. I'm currently at line 2 of my permutations. Okay, so what is word at this point? Word at this point is a string ABC. Is the length of word actually equal to 1? Well, the length of word is 3. This condition is false, meaning this piece of the loop, this piece of the condition statement will not execute. So let's do a step over and let me show you that. So if I do a step over, I come back to this point, come back to the next instruction inside the else part. At this point, I'm going to call my recursion. Again, I'm just calling a new method permutations. But at this point, the problem I'm trying to find is the permutations of a smaller string of length n minus 1. So if I do a step into, if I go specifically into this method, what happens is that now I can see that permutations has called permutations again. But at this point in the inner permutations recursion call, string word happens to be a smaller problem of size 2, but I have just BC. The original problem was of size ABC. BC is the new problem size of length 2 when the recursion gets called again. And you can see at this point that the problem size is getting smaller. This condition is still false. Because it's still false, if I just step over, I'm going to call recursion again. I'm going to go one level deep, meaning that I'm going to have another stack frame getting created at this point. Another stack frame. As so far have permutations calling permutation, but this permutation that is currently selected is going to call permutation again. When that happens, let's just step into, and I can see I have 3 permutations right there. 3 permutations is a recursion. And at this point, my string is basically of size 1, and the permutation on that smaller string of size 1 is just the character itself. So let's do that. Let's do a step over. At this point, I'm going to return back, and I know how to solve this problem. If a string of length 1, the permutation of that string is going to be a list of just that character. So I'm just going to return back that list. But where am I going to return back to? I'm going to return it back to, so again, just to clarify, this piece over here is going to be a list containing just C. Where does the C go to? The C goes from over here to the next item on my stack. So remember, when this method returns, this function gets taken off from the stack, because you have already returned. The function has terminated. When a function terminates, it gets taken off from the stack, and the calling sequence goes back to the next item that happens to be the topmost item on my stack, which is over here. So this piece over here, permutations, is going to get back a list of just C in it. And let's see what it's going to do with that. So with that C is now going to get me all the possible permutations. So first let's do this. Let's just do a return. Okay, there you go. The permutations got popped off. I've come back to the next permutations function, which happens to be what I was trying to solve for, word as BC. What is perms going to contain in this case? Remember, this is a local variable, and this is going to contain, if I do a step over, you can see that it actually contains the list with just one character, which is the permutation of the problem when word was just the character C. So given that, I can now solve for all possible permutations for my string BC, and all I have to do is, it's really simple. I'm just going to now, the way I'm going to solve this problem is I'm just going to take C, I'm just going to position B before it, and I'm going to position B after it. Okay, so all possible permutations for the string BC. Okay, the way I'm going to solve this is, I'm first going to take this list C, which is just the item C, and I'm going to position B before it, and then I'm going to position B after it, and that is going to give me back a new list of all possible permutations for the problem BC. Okay, so let's see if I can actually get this. The way I'm going to get this is, let's keep a track of what this result is going to be. So let's do a step over. Result is currently empty. I do a first pass on my permutations. At this point, I can see my local variable is containing C, and then I'm going to go across every single of the list inside range, and at which point I'm going to have I equals to 0, at which point the result is going to contain BC. Now remember, this loop runs once more, the inner loop runs once more, at which point result becomes contains B, C, and CB. I got back all the possible permutations for my smaller problem string BC. Once I've got that, this method, this part of the recursion completes, right? It completes. It's going to say I'm going to return back the result. What is result here? Result at this point is going to be contain this list. Where does this list go to? It goes to right at the next step of your recursion. So let's see that. So let's do a step over. The function returns, meaning this item gets taken off from the stack. I just have the first innermost permutations method about to continue its execution, which was the original problem of trying to figure out what are all possible permutations for the string ABC. If I just step over, I'm going to get back a list of all possible permutations on a smaller problem of BC right there. And I just need to do the same process again to get back all possible permutations for the original problem ABC. So if I do, let's put a breakpoint here and let's just continue this. So let's just resume the program and see what happens. At that point, result is going to be ABC, BAC, BCA, ACB, CAB, and CBA. So if I return from here, and now I can print it out on the console. So if I come back to my console, I can see the actual output getting printed. So I hope this was useful, at least getting an intuition as to how I'm able to solve the permutations problem using recursion.